Hello guys, today is the third lecture for you guys and today we'll be studying types of reactions and rest of the part of the chapter. So we'll try to finish it off today and we'll see different type of reactions which are happening. So we have already learned the basics of how to write a reaction, how to balance reaction, what all should be prerequisite when we are writing a chemical equation. So all these things we have already understood. Now how to implement it and how to analyze all different type of chemical reactions is what we are going to learn today. Okay, so let's start with types of chemical reactions. So when we talk about reactions, there are millions of reactions happening all around. Millions of reactions happening. But still we can broadly categorize them into 5 different type of chemical reactions. Okay. And those chemical reactions are the basis of understanding that how exactly the reactions are taking place. So what are different type of chemical reactions? First is combination reaction. I write reaction as RXN, you write it as a proper reaction. Next is decomposition reaction. Third is displacement reaction. Fourth is double displacement reactions. And fifth is redox reactions, which are also called as oxidation and reduction reactions. Now we will be going to each and every category one by one and we will understand how these reactions and why these reactions are called by their specific names and how the reactions takes place. Okay, so we will be starting with the combination reaction first. So let's start with combination reaction. So let's understand what are combination reactions. To understand combination reactions, you really don't require a rocket science sort of thing. You just need to understand the meaning of combination itself. So what is combination? Combination means combining substances together. So basically multiple substances you have, you're combining them and making them one. So that's exactly what happens in a combination reaction also. So you have multiple reactants, you're just reacting them together, and while reaction, they are combining with each other, they are combining and becoming one single product. This is your combination reaction. So what are combinations? Combination reaction, 2 or more than 2 reactants. I hope you know what are reactants. Reactants are the ones which are on the left hand side and they initiate the reaction. They react together and eventually form a compound which is called as, they form different compounds which are called as products. So 2 or more than 2 reactants when react together and combine to form only one product, then the reaction is called as combination reactions. So what all different type of reactants can we have? We can have a combination of element plus compound. Basically one element, other is a compound which is reacting together. So this is the reactant combination I'm telling you. So either one element, one compound can react, or one element can react with another element, or one compound can react with another compound. So it can be any combination basically. It can be, if let's say 2 reactants I have, then one can be element, another can be compound, both can be element, both can be compound. So basically it can be in any random combination. And when they'll combine, they'll give you the respective product. And that product is going to be one single product, not the multiple products. So this kind of reaction is called as combination reaction. So basically it is almost like if you have taken 2 different clays and of 2 different colors, let's say one is pink color, one is black color, you have mixed them together, you have just merged them up completely. So we are not mixing it up over here, we are breaking the bonds and the new bonds are forming. So this is something which you have to understand. So we are not making mixture of it, we are combining them together by reaction. So they are reacting together and forming a one different compound altogether, and that compound is the product. Okay, so it is like if you have taken iron pieces, and if you have taken or if you have taken iron flakes, and if you have taken sulfur pieces, and if you have just kept them together in a bowl, then it is a mixture. But if you have heated up them together and you have let them react together, then it will form a different compound altogether. Earlier, after mixing also, iron was different and sulfur was different. But here, when you take iron flakes and you'll take sulfur, and when you'll heat them up together, it will form a different compound altogether, and that will be one single compound that will be called as ferrous sulfide, and that is going to be your combination reaction. Okay, so we'll see some examples of combination. So first example of combination reaction is, which we have done in the earlier lectures also, that is reaction of magnesium with oxygen. Magnesium is solid, oxygen is gas, and then these two are burnt together in the laboratory. So basically what we take is, we take a magnesium ribbon, and then we burn it in the presence of oxygen and through the Bunsen burner what you have in the lab. So when you burn it, what will you see? After burning the magnesium ribbon, it will get converted into white color ashes. Okay, and when it will burn, it will give you dazzling white flame. So that is how the reaction takes place, and that will be your look and feel of the reaction. But what will be the product forming? Product will be formed as MgO. This is solid. So this is magnesium, this is oxygen, and this is magnesium oxide. Magnesium oxide. So now what we can observe over here, magnesium was one reactant, oxygen was another reactant. Both of them were individual metals. Both of them were individual elements. They reacted together by burning and formed one single product, that is magnesium oxide. Right? Similarly, you can have other reaction as carbon burning with oxygen. So basically I have taken carbon and I am burning it in the presence of oxygen. It will convert into carbon dioxide. It's a gas. Again, carbon was one element, oxygen was another element, and they combined to form carbon dioxide. Similarly, you can have hydrogen gas reacting with oxygen gas. So when you will burn them together, it will form H2O. Liquid. This is water. So in all of these reactions, if you can observe, what we are taking here is, we are taking two different reactants, and the product which are forming are one single product in each case. Okay, so all these three examples were the examples where we had taken two different elements. Now I'll take some example where we are taking a combination of an element and a compound. So let's see the fourth example. What is the fourth example? So fourth example is carbon monoxide reacting with oxygen. Carbon monoxide is a compound, oxygen is an element. Both of these are combining together. So basically, if both are reacting together, will form carbon dioxide gas. So here, this is an example where one compound and another is element taken. Now I'll show you one more example where you have two different compounds taken and they are combining and forming one single compound. So if you take NH3 gas plus HCl liquid or aqueous or dilute means dissolved in water. Liquid means its state is liquid itself. Basically, that compound itself can be liquid, not dissolved in water. And aqueous also means dilute. So aqueous and dilute is basically the same thing. Okay. So HCl and NH3 reacted together and formed NH4Cl gas. So again, here what we had taken two different compounds and they reacted together and formed NH4Cl, which is basically white dense fumes. So this is quite visible reaction, white dense fumes. So if you have dipped your let's say glass rod, one glass rod you have taken, you have dipped it in the HCl and then you are bringing it closer to the NH3 gas, you will see white dense fumes coming out of your glass rod, and this is the observation of this reaction. Those white dense fumes form due to the preparation of NH4Cl or due to the production of NH4Cl. Okay. Now for this example, I had taken NH3 as a gas and HCl as dilute, and then your NH4Cl is coming out in the form of vapors or gas and white dense fumes are visible. Similarly, the same reaction can be written as NH3 in the form of liquid or aqueous. Basically NH3 is dissolved in water, and you have taken HCl as a gas, and then the reaction is happening together. So basically now you have dipped the glass rod in NH3, liquid NH3, and now you're bringing it closer to the HCl gas. Then also the same thing will happen. NH4Cl in the form of gas will come out, and white dense fumes will be visible. So this is in case when you have either of them in the aqueous or dilute form. If let's say NH3 and your HCl both are in the gaseous form, then what will happen? If both are in the gaseous form, then your NH4Cl will be formed in the similar manner, but the state will change. So state of NH4Cl will change, and this will become NH4Cl solid, but again it will be white solid. Okay, so few more examples. I had given you in the last class also that if you take calcium oxide, what is calcium oxide called? Calcium oxide in general language is called as quicklime. It's a solid. Okay, otherwise it is called as calcium oxide. Calcium oxide. If it reacts with water, that is liquid, then this reaction was an example of an exothermic reaction, and it forms calcium hydroxide CaOH whole twice, and this used to call as slag lime or calcium hydroxide. Slag lime is a general word. Basically in the normal language you can call it as, it's not a scientific name, and calcium hydroxide is the scientific name, and lot of heat was getting released. So this is how the reaction was. Now look at it. Calcium oxide is again a compound, and H2 is also another compound, and both of these reacted together to form one single product, that is calcium hydroxide. This is called as slag lime also. This is an important reaction. Now because we are learning about this reaction, I'll tell you something about calcium hydroxide, which is not the part of combination reaction, but just for your information. So if we talk about calcium hydroxide is something what we do for the whitewashing on the walls. So we use it for whitewashing. So whenever the whitewash happens on the walls, you will put the CaOH2 on all the walls, and what will happen after putting it? Basically in the environment there is carbon dioxide gas also present. So CaOH whole twice, that is slag lime, will start absorbing the carbon dioxide gas and will start reacting with it. Okay, so whatever carbon dioxide is in the surroundings, it will absorb, it will start reacting with it, and it will become, so CO2 gas it will react with and will form calcium carbonate, plus water will get released. So water will get released and calcium carbonate will form. This calcium carbonate makes your wall much more shiny as compared to when you had just put CaOH whole twice. So basically it forms calcium carbonate, which is very white shiny substance, and that's the reason why it gives you a little glossy kind of effect when once the whitewash is done. Not exactly glossy, but it becomes much shiny as compared to the earlier stage. Okay, and that is due to the formation of CaCO3, that is calcium carbonate. Okay, so these are the examples of combination reaction. I hope when somebody will give you the set of reactions and they'll ask you to identify which one is the combination reaction, you'll be able to identify. Moreover, now we have written almost 6 examples of combination reaction. If somebody asks you to write 2 combination reactions, you can write it. Okay, so let's come to the next reaction, that is decomposition reaction. So what is decomposition reaction? To understand decomposition, again we will have to understand the meaning of decomposition. So meaning of decomposition is nothing else but breaking down a bigger particle or bigger substance into smaller substances, or smaller and simple substances. Okay, so now when we talk about decomposition reactions, what exactly happens in them? We take a bigger huge molecule of reactant, okay, and then it breaks down into smaller molecules. So basically you will have one big molecule as a reactant, and in product you will get multiple small molecules. So doesn't it look like completely opposite to the combination reaction? In combination, what we were doing, we were taking the smaller molecules or atoms or elements or compounds or whatsoever, and they were combining together and were forming one big molecule. Now here we are just doing the opposite of it. We are taking a big molecule and then we are doing some activity on it which causes the reaction to happen, and then that bigger molecule breaks down to smaller particles. Okay, so now in this, the condition will be only one reactant will be there, one reactant, big molecule, will break down into simpler molecules, simpler multiple molecules in product. Correct? For example, if I have, let's say, AB, this is a one big molecule, and then it is breaking down into A plus B. Definitely this doesn't seem like a reaction, but I've just told you for just a reference. AB was a big molecule, it broke down into A and B. Now what causes this reaction to happen? So there can be multiple things which can lead to this reaction towards the product side. And what are those things, or what are those conditions? So decomposition reaction can take place in the presence of heat, light, and electricity. So basically heat can cause the breakage of the big molecule, or light can cause the breakage of a big molecule, or electricity can cause the breakage of the big molecule. So we call these reactions which comes under these categories are called as heat decomposition, or decomposition by heat, or can be also called as thermal decomposition. Now light decomposition. In light decomposition, light falls upon a bigger molecule and it breaks down that bigger molecule into the smaller pieces. Okay, and that is called as light decomposition. Similarly, we have electricity decomposition. Electricity decomposition is nothing else but you have taken a substance, you have supplied electric energy to it, and then the bonds will break of that molecule, and that particle will dissociate into these smaller particles. Okay, so another is electricity decomposition or electric decomposition. So we will be basically discussing all of these three types. All of these energies are basically helping in breaking the bond. So basically when we talk about heat, heat is helping in breaking the bond among the atoms in the bigger molecule. Same is the case for light, and same is the case for electricity. So basically a decomposition reaction can happen in three conditions: if heat energy is supplied, or light energy is supplied, or electric energy is supplied, and we will see the examples of each case. Okay, so let's first talk about heat decomposition, heat or thermal decomposition. And let's see the examples of thermal decomposition now. So first example is when limestone is heated. CaCO3 is nothing else but limestone. You should know all these common names also. We know CaCO3 is calcium carbonate. You need to know this is called limestone. Okay, this limestone, when heated, it breaks down into calcium oxide and carbon dioxide. What is calcium oxide is called as? It is called as what? Quicklime. So it is called as quicklime and carbon dioxide. So what we can see is calcium carbonate was made up of one calcium, one carbon, and three oxygens. It broke down into two smaller pieces, one with calcium and oxygen and another with carbon dioxide. And that is when heat was supplied. Okay, when heat was supplied, calcium carbonate broke down into calcium oxide and carbon dioxide gas. Similarly, if I talk about the next compound, that is potassium chlorate, KClO3 is called as potassium chlorate. All these names you will have to remember. This is called as potassium chlorate. Okay, and when this particular molecule is heated, or when this compound is heated, it breaks down into KCl and oxygen. KCl is your potassium chloride and O2 is your oxygen. I think I have not balanced oxygen part of it. So whenever you're writing the reactions, make sure that you balance the reaction. Without balancing the reaction, as I have earlier also mentioned, that reaction will be considered as invalid. That reaction will be wrong no matter how right you have written the reactants and products. So here it will be 3 over here. Okay. Next example is of ferrous sulfate. FeSO4 is called as ferrous sulfate. This is green color solid. green solid. And when this is heated, it gets converted into ferric oxide. It gets converted into ferric oxide, and this is brown color solid. Brown solid. Along with that, it breaks down into sulfur dioxide and sulfur trioxide gas. Sulfur dioxide and sulfur trioxide. So if you see, all these reactions are basically showing you all those kind of changes what we had discussed, that what all different changes happen when you talk about a chemical reaction. A color change is happening, state change is happening, sulfur FeSO4 was solid and the gases are forming, moreover the gas is getting released. So all these kind of changes what we had thought are happening in the reaction mixture. Okay, so now when you see these reactions, what you can see, that single reactants are reacting, and basically they are not reacting, they are basically breaking down into the smaller pieces. Their existing bonds are breaking and they are breaking down into the smaller molecules. Okay, so these are some reactions of thermal decomposition. Let me just do one more important reaction of thermal decomposition. All of these three reactions are very important for your school exam. They do ask the reactions directly. What happened? What observation do you see when we heat the ferrous sulfate crystals? So that time you have to mention that the green color crystals will get converted into brown color crystals, because that color change will be visible. Your gases will get released, but you won't be able to identify which gas is which, because they don't have different color. But observation wise, you will mention that the green color crystal will get converted into brown color solid. Okay, or green color of FeSO4 will change into brown color. So all these reactions are very, very important in terms of their observation, in terms of their category in which they are. So they ask you these questions quite directly. Okay, let's see the last example of heat decomposition. So next example is that if we take lead nitrate, PbNO3 whole twice is nothing else but lead nitrate. Okay, this is your colorless solid, and when we heat it, it breaks down into multiple smaller molecules. One is lead oxide, and this lead oxide is yellow color solid. Yellow color solid. Then it breaks down into nitrogen dioxide, dioxide, and this is brown color gas. So it will be quite visible. Brown gas. The brown gas coming out of the test tube is visible. So two visibilities are there when they ask you what is the observation. One is yellow, formation of a yellow color solid. Second is formation of the brown gas. Plus oxygen will get released. So these reactions are not only important because these are the part of decomposition reaction, but these two reactions are specifically more important because there are some observations to see. You can see the change happening. You can see the change happening by the color change. Okay, so both of these reactions, ferrous sulfate reaction and lead nitrate reaction, both of these reactions are very, very important. Okay, so these are some examples of thermal decomposition. Now we'll talk about light decomposition. So next is electric decomposition. Electric decomposition is also called as electrolytic decomposition because many of the times or most of the times the reaction takes place in an electrolysis chamber. I hope you know what is electrolysis chamber, which has one cathode, one anode, and we keep the mixture of anything, any substances like any solution we keep inside the, basically this looks like this. So basically this is your some solution or anything in the molten form, and these are anode, cathode connected to a battery, and this battery basically supplies the electric energy, and these are two electrodes, one plus, one minus, like that. And whenever the reaction takes place, the solution breaks down into the smaller particles, or the molecules of the solution breaks down into the smaller particles. Negatively charged particles go to the positive electrode, and the positive particles go to the negative electrode, get deposited over there in the form of gas or solid. So this I hope you would have learned in the previous classes also, right? So this setup is called as electrolysis setup, and this is what we use for doing this electric decomposition. Let's say I have taken water in the liquid form. I have filled it in this setup. Okay, this is your anode, and this is your cathode. Negatively charged terminal is your cathode and positively charged terminal is your anode. Now when you'll start supplying the electric current through the battery, what will happen? The water molecule will break down into the smaller particles, that is hydrogen and oxygen, and those hydrogen and oxygen molecules will go out as a gas from the respective electrodes. So your hydrogen gas will come from the area that is cathode, because hydrogen will break down as, see, when you talk about water will break down as H plus and 2O2 minus. I don't know whether you know this or not, but water, when breaks down, there is a oxygen, hydrogen and hydrogen bond. Hydrogen is more electropositive, or you can say hydrogen is the one which forms with the plus valency, whereas oxygen forms with the negative valency. So when the bonds will break, these will break in such a way that the hydrogen will come out as H plus and oxygen will come out as oxygen 2 minus. So it will have, H will have plus valency and oxygen will have minus valency. So this hydrogen will go to the electrode which is negatively charged, will take the electron from there. So at cathode, what will be happening? At cathode, H plus will go to cathode, will ask for an electron. So one E minus is nothing else but an electron. So hydrogen will go to the negative electrode, will ask for an electron. This will be electron rich electrode, and it will give electron to hydrogen. Hydrogen had one electron less, it will give it one electron, so it will become hydrogen atom. Two such hydrogen atoms will combine together to form hydrogen gas, because obviously not only one H plus will go, multiple H plus will go and will get converted into hydrogen atom. Now these two hydrogen atoms will combine and will form hydrogen gas and will get released from the cathode side. Similarly, at anode, what will happen? O2 minus will go to anode, which is a positive terminal. It has excess of electrons with it. It has 2 extra electrons. So it will give away its 2 electrons. It will say, please let me get rid of this electron. So if it will give away these electrons, because this anode is electron deficient, then oxygen will get converted into normal oxygen atom. Only O, no charge on it. Similar two oxygen atoms will combine and will form O2 gas. You got my point? So basically I have broken down the water into its respective ions with their respective valencies, and then according to their valency they'll go to the respective cathode or anode, will take electron or will give electron, will become neutral, and then will form the respective gases. And it will get released on the respective electrode. So hydrogen will get released at cathode, whereas oxygen will get released at anode. And this is due to the electric supply what we have given. Very similar thing will happen with the NaCl also. What we have taken here is molten NaCl, not liquid. I mean, not aqueous. It is not dissolved in water. It is molten. Basically, we have whatever the table salt we use at home, we have literally melted. So molten NaCl I have taken. When we'll pass electric current through it in such setup, so NaCl breaks down into Na plus and Cl minus. Na is a positive ion, will go to what? Cathode again. Correct? Cathode is a electron rich species. So what will happen? I'll write the reaction over here. At cathode, Na plus will gain one electron and will become Na. Na solid. It doesn't have to form the molecule. Na in its own is a metal, and it will get converted into the solid form and will get deposited over the cathode. Okay. Whereas what will happen to chlorine at anode? Cl minus has a negative charge. It doesn't want to stay with the negative charge, so it will give away its electron there and will become normal Cl. These two chlorines, such two chlorines will combine to form Cl2 gas, and that gas will get released from the anode side. So Na will get deposited at cathode and chlorine will get deposited at anode. So that's how the electrolysis happens and the things break down. Exactly same thing will happen with the aluminium oxide. This is sodium chloride. I have not mentioned the names, I'm sorry. This is sodium chloride. This is water. I've written up because there is less space. And this is aluminium oxide. Aluminium oxide. This is again in the molten form. Now what will happen? Aluminium's valency is Al is 3 plus. So when Al2O3 will break, Al will break as Al3 plus and oxygen will break as O2 minus. Again Al3 plus will go to cathode, will take the electrons from there at cathode. Al3 plus will take 3 electrons to neutralize itself, will become Al solid and will get deposited on the cathode. Whereas when you talk about oxygen at anode, O2 minus will lose its 2 electrons which it had in excess, will become oxygen. 2 oxygen atoms will combine to form oxygen gas and will get released from the anode. So reaction is happening in exactly same fashion in all the 3 cases. So this is how electric decomposition takes place, and that's how electricity helps in breaking the bonds in the bigger molecules. They break down into the smaller ions and those ions go to the respective electrodes, get electrons from there or lose electron there and then get deposited or come out as gas from those respective electrodes. This is your electric decomposition. This is also called as electrolytic decomposition or electricity decomposition. You can call it anything. Okay. Next and the last type is light decomposition. So next is light decomposition. And light decomposition is again the same thing. When light falls upon a particular molecule which is sensitive to light, it will break its bonds and the molecule will break down into smaller molecules. So here the bond breakage happens through the light energy. Now in such cases, most of the compounds what we use or most of the compounds which are sensitive to the light are the silver based compounds. Okay. So for example, if I talk about silver chloride, AgCl, this is white color solid. As soon as the light will fall upon it, this light can be through sunlight, can be through bulb, can be any means of light. It need not to be necessarily sunlight only. Okay, so you have to keep these substances in dark, else when they'll come in contact with the light or when the light falls upon them, they do not remain in their own molecule state and they get converted into something else. So if the light energy is has been supplied to AgCl, it will break down into silver and chlorine gas will get released. Chlorine gas is yellowish green color gas which will be visible, and your silver is a grayish white metal. So you can see this change happening, that your white solid has started releasing the yellowish green gas as soon as this AgCl came in contact with light. Very similar to that, I can take AgBr, that is silver bromide, and this is also, and this is pale yellow color compound. So when this will come in contact with light, it will break down into again silver and bromine gas. Now the color of the bromine gas is reddish brown gas. So again this will be a very visible reaction, that your yellow solid has got converted into grayish white solid with the release of reddish brown gas. This specific reaction, this one, the one which we are talking about, in which we are talking about AgBr, this used to be a very important reaction in the older times when there used to be the film kind of setup in the cameras, that you used to put a film over there and then we used to do the photography, especially the black and white photography. At that time, this component AgBr also used to be the part of that, that the compounds which are present on that photography film, and it used to decompose due to the light, and that's how the black and white color used to come. Nowadays also we use it, but nowadays the things have become more digital. Earlier this was very widely used in the photography purposes. So this AgBr, when comes in contact with light, breaks down into Ag and Br. So this shows a sensitiveness towards the sunlight, and that's how it used to give us the print of black and white. Wherever the light used to fall, it used to be white. Wherever light could not fall due to the presence of the person directly, that part used to remain as black. If you want to understand how exactly it used to happen, you can search, you can research it on the Google, you can understand the process, how this AGBR, it was not just AGBR, there were many other compounds which were light sensitive, and they used to be the part of black and white photography. But you can go through it, you can figure out how the whole mechanism used to be there. Okay, so this is about your three different kind of decompositions: thermal decomposition, light decomposition, and electric decomposition. There are thousands of decomposition reactions happening inside our body also. For example, what food we eat, that is a complex carbohydrate. When it goes down into the body, it breaks down into smaller particles and eventually sugar, and then that sugar gets converted into glucose. That itself is a decomposition reaction. So our body has millions of reactions happening. Your food getting converted into proteins, vitamins, minerals, and breaking down into these particles. This is a decomposition reaction. They can ask you such type of questions: what type of reaction is this, which are not the generic which are not the reactions like this, but they'll just mention them in a generic statement, that digestion of the food or breaking down of the carbohydrate into sugar. All these are decomposition reactions taking place in our body. Okay, next we will talk about displacement reactions. So next we are starting displacement reactions. So as the name suggests, displacement means displacing one thing from another. For example, if I have, let's say, A, B, and then C comes from somewhere, and it has enough strength to displace B out of it, the new compound will become AC plus B. Or you can also talk it in such a way. Let's assume there is a swing in which a little kid is sitting. Okay, small kid, and then comes a big bully boy. Okay, and then he wants to sit on that swing. So what will happen? This kid is swinging nicely, and this kid will come and will say, "Oh boy, just get out of this swing. I won't sit on it." That other guy will just stand up from here, will go crying to his mother, but he won't be able to do anything apart from that. So he'll cry, he'll go to his mother, but he won't be able to do anything, and this big bulky boy will come and sit over here. So what do we need if we want to displace something? The other substance which are going to displace the previous species, then it should be strong. So the same thing is happening over here. Let's say I've taken A, B, and there is a C, and we are taking C as a much stronger element than B. Then what will happen? The C will kick out this B from A and will form the bond, that is AC and B. This is called displacement. So basically, a stronger element or stronger metal kicks out the weaker metal and then get displaced at its position and form the new compound. So how do we even get to know that a particular metal is a strong metal or a weak metal? A particular element is a strong element or a weak element? So we basically refer one reactivity series. So this is our reactivity series which I have mentioned over here. Now when we go from top to down, reactivity of the elements decreases. This is not only metal series, this has one non-metal also, that is carbon. Okay. So reactivity decreases when we go from top to down. When we go from top to down. That means the most reactive metal is potassium. That means it is the most powerful one and can displace any other element, any other metal to be precise. Then comes sodium, then calcium, then magnesium, aluminium, zinc, iron, tin, lead. Hydrogen and carbon are two non-metals in this group. Hydrogen is a benchmark. Beyond this, whatever the metal comes, that is very less reactive. Okay. So beyond hydrogen, there comes copper, silver, and gold, and these are very less reactive metals. Okay. Now, when I say that potassium can displace any of the metals over here or elements over here, if I say that I had potassium with something, let's say I had potassium with chlorine, and then comes calcium from somewhere, which is lesser in the reactivity, will it be able to displace potassium from here? No. Why? Because the reactivity of calcium is lesser than potassium. So less reactive substances will not be able to displace, or less reactive metals will not be able to displace the strong metals, whereas strong metals will displace the weaker metals. This is the whole basis of displacement reaction. So you have to remember this reactivity series. And how will you remember? You can make your own tricks to remember this, and there are few known tricks also. I'll just tell you which is the known trick. So here is the trick. Please for potassium, stop for sodium, calling for calcium, D for magnesium, A for aluminium, careless for carbon, zebra for zinc, instead for iron, try for tin, learning for lead, how for hydrogen, copper for copper, sales for silver, and gold for gold. So basically, this is the whole series which you can learn through this sentence. Please stop calling me a careless zebra, instead try learning how copper saves gold. If you just remember the sentence, see, it is quite easy. I also remember it the same way. So if you just, or you can make your own. So it's completely up to you. So this way you can remember all the elements in these series. Okay. This is not the only reactivity series. So there are multiple more elements in the reactivity series, but we have to just get bothered with these elements. We will not be getting into the larger reactivity series. What comes in the higher rates. Okay. So this is your reactivity series. Whenever we will be doing displacement reaction, we will be referring this reactivity series for solving the questions or solving the reactions. So now we'll see some examples of displacement reactions. So now we'll discuss examples of displacement reaction, but before we discuss examples, we need to understand there are two visible changes which we can see when a displacement reaction is taking place. One kind of change which will be quite visible will be color change. So basically one substance is getting converted into another substance, and the other substance has a different color, whereas the one which started the reaction, basically reactants and products have different color. Secondly, release of gas. Release of gas. These are two very common changes which you will see, and observable changes. If somebody asks you whether what happens in this reaction, what is the visible change, you will be able to see. So these are two quite visible changes which you can detect and you can report. Apart from that, definitely change in state also happens in few conditions, in few reactions, and as well as temperature change also happens in few reactions. So basically all different type of changes which you would have seen or which we would have studied, all can be read through, seen through in these reactions, but these two are the most common ones: color change and the release of gas. Okay, so now let's take the first example. First example is copper sulfate solution. I have not mentioned copper sulfate, I'll just write down. SO4 2 minus is a sulfate ion. So copper sulfate reacted with magnesium. Okay, when they have kept together, just look at the metal over here. One is copper and another is magnesium. Let's see its positioning over here. So magnesium is above the copper. So basically the copper is less reactive and magnesium is more reactive. So definitely magnesium is stronger than copper, can easily replace it. So it will become MgSO4 plus copper. This copper sulfate was a blue color solution, but when it reacted with magnesium, the magnesium sulfate is a colorless solution. So this will become colorless and copper will come out in the reddish brown granules. So it will come out as solid. Now when you are doing these reactions, few things which you have to take care of is the valencies, and when you are displacing, the valencies should not go wrong. So when you talk about CuSO4, it is in the aqueous solution. Mind it, this is the bond between copper and sulfur, and this is an ionic bond. So when you will dissolve it in the aqueous solution, or when you will dissolve it in the water, it will basically split into its respective ions. So copper sulfate will split into Cu2 plus and SO4 2 minus. Got it? Now we have magnesium. Magnesium's valency is also plus 2. So we have magnesium. Magnesium will also behave as Mg2 plus. Okay. And or you can say magnesium is present over here. Let me just write it over here. I'm rubbing off this reactivity, so should I rub it? No, what I'll do is I'll rub this and I'll explain it to you over here. Okay, so how exactly the reaction took place, let me explain. So CuSO4 broke down into Cu2 plus and SO4 2 minus, and magnesium is present over here. Okay, but magnesium has no charge over it right now, though it can show +2 valency, but it doesn't have any charge right now. So what this magnesium will do to react with copper? First of all, it will become ionic. First of all, it will gain the charge. Basically, by losing electron or by gaining electron, it will get the charge over it so that it can react with sulfate ion. So how will magnesium do it? Magnesium will lose 2 electrons and will become Mg2 plus. This is what the valency of magnesium is. How will it gain that valency? By losing 2 electrons. So it has lost 2 electrons, became Mg2 plus. Now this Mg2 plus will react with SO4 2 minus. So Mg2 plus SO4 2 minus reacted together. Basically both have same valencies but opposite valencies. So it will become MgSO4. And now what we are left in the solution? We are left with copper, Cu2 plus and 2 electrons which were released by magnesium. So what this copper will do? Copper will gain these 2 electrons because none of the species are stable or none of the ions are stable in general. So either they should be in the reaction format, basically they should make some bond with something, or they should be in the neutral state if they are not bonding with something. So copper 2 plus will gain those 2 electrons which were given by magnesium and will become copper, and this will be the solid form and this will be the aqueous form. So this is your ionic reaction of this displacement reaction. So they sometimes ask, write the ionic reaction of it. So ionic reaction is nothing else but break down the species into respective ions and see what is gaining electron, what is losing electron. So here your magnesium is losing electron, whereas your copper is gaining electron, and then magnesium and sulfate ion reacted together to form MgSO4 aqueous. Okay, and the other metal is coming out as solid, and that is reddish brown granules. You should remember the colors of the species forming as well as their state. Both are very important. Understanding this ionic structure is also very, very important. Otherwise you will mess up with the valencies of the species and the compounds formed will be wrong. So you have to be very, very careful. So I will be showing you this ionic reaction in each case. Ionic reaction in each case. All the reactions what we are going to discuss over here, I will show you the ionic reaction of all of them. Okay. Now come to note this down and then I will rub this off. Next example is copper sulfate reacting with iron. Copper sulfate solution reacting with iron solid and forming FeSO4 and copper. Again, this is copper sulfate solution, this is iron. It is forming ferrous sulfate. I hope you know what is ferrous, what is ferric. If you don't know, I'll anyway share a list with you guys. Please go through those ions. You have tests coming up at this month end. If you don't know that ions properly, you will not be able to write the compounds rightly, and then in that case you will lose the marks. So let's see the ionic reaction of it. Again, you have CuSO4 in the aqueous medium. That means it is in the solution. It will break down into the respective ions, that is Cu2 plus and SO4 2 minus. Then comes your iron. Iron has no charge, but it has to react with sulfate, so it will gain the charge or it will get a charge by losing electrons. So valency which iron can show is +2 and +3. It will lose 2 electrons, will get Fe2 plus on it. Right? Now, because iron is much reactive than your copper, this Fe and SO4 will go together, will form Fe2 plus SO4 2 minus, will combine to form FeSO4. This is ferrous sulfate. Now what we are left with? We are left with copper and 2 electrons. Copper will gain these 2 electrons. Copper ion will gain 2 electrons and will become copper solid or copper metal. So this is how the reaction in the ionic manner also. This is the ionic reaction of this displacement reaction. What kind of color change was visible? Copper sulfate solution was blue earlier, and then it formed the ferrous sulfate solution which is green in color, and the copper which is forming the reddish brown is in the reddish brown granule forms. Okay, it will be suspended in the solution or will settle down in the solution. Now next reaction is copper chloride solution reacting with lead solid. So the color of the solution is green and then it is going to become colorless. This is the observation. Plus you are going to get reddish brown granules, that is copper granules. Lead is definitely more reactive than copper. Will displace it and will form PbCl2 plus copper. Again we'll look at its ionic reaction. CuCl2 in the solution will break as Cu2 plus and Cl minus 2Cl minus. Then lead will lose 2 electrons and will become Pb2 plus. So Pb2 plus chlorine will react together, will form PbCl2 because minus one valence for chlorine, 2 for lead, and then Cu2 plus will gain these 2 electrons and will form copper. So this is what our products are. Okay, this is in the aqueous form, this is in the solid form. This is aqueous, this is solid, and the color change is also quite visible. Next is, so these were the reactions where we were talking about the metals displacing metals and we were seeing a lot of color changes happening. Okay, now next few set of reactions we will see the evolution of gas. Color change may or may not happen, but you can see the gas coming out of the reaction mixture. So what we have taken iron reacting with HCl. So HCl is an acid and iron is a metal. So this is basically a reaction between a metal and acid also, which we will be doing in third chapter, that is metal and non-metal chapter also. So metal reacting with acids is one category of reaction we are going to do in metal, non-metal. In the same set of reaction I am doing it here also. So it will be repetitive reaction over there. So now when iron is dissolved in HCl, look at the iron's position. Iron is above hydrogen, so it will be easily able to displace the hydrogen and will form FeCl2 plus hydrogen gas. Now again if I write the ionic equation of it, how will be the ionic equation? Your HCl will split into H plus and Cl minus. Fe will lose 2 electrons, will become Fe2 plus. Correct? This Fe2 plus and Cl minus will come closer, will react with each other, will form FeCl2 plus. You have hydrogens over here. So see, I have not done the balancing yet. Okay, just understand this part. So what is happening? You have formed FeCl2 and chlorine. Hydrogen is H plus. It basically requires only one electron to neutralize itself, right? Or you can say to make itself neutral. But I have 2 electrons over here. So what will I do? I'll take 2 hydrogens which will react with 2 electrons and will form H2 because only H is also nothing. One single atom of hydrogen and another atom of hydrogen will combine to form hydrogen gas. So basically when we do the balancing, 2 HCl will come over here. So if I look at the reaction, you can see this way also. There is H2 over here and there is one single hydrogen over here. And in fact in HCl also, if you see, there is one chlorine here and we have used 2 chlorines over here. So I have to do the balancing over here. Fe and Cl when reacted together form FeCl2. So there must be one more chlorine from somewhere, right? So that balancing has to be done. And this becomes HCl. It gives you 2H plus and 2 Cl minus. Now these 2 Cl minus are reacting with Fe, forming FeCl2. And 2 hydrogens are giving 2 electrons and forming H2. So this is what ionic balancing also. I'll just explain you this once again. Okay, just once again try to understand how it is happening because I did it in a very quick manner. So HCl broke down into H plus and Cl minus. Fe broke down by losing 2 electrons into Fe2 plus. Okay, now I have got Fe2 plus Cl minus to form FeCl2. So there are 2 chlorines over here. So I need to balance it over here also. So I will write 2 Cl over here. Correct? But what was the source of this 2 chlorines? The source was HCl. So basically I have to write 2 HCl over here, which will basically release 2 hydrogen and 2 chlorines. Correct? Now 2 of these hydrogens will gain the 2 electrons released by iron and will become H2 gas. So now the equation is balanced. So they ask you sometimes to do the balancing of an ionic equation. That's how you have to do it. Okay. Now Come to the next example. Next example is, so what we can, okay, in the previous example, what we can see, the release of hydrogen gas. How do we detect the hydrogen gas? If you bring the burning matchstick near the place where hydrogen gas is getting released, we hear the pop sound. If it gives you the pop sound, that means the gas getting released is hydrogen gas. Next is reaction of sodium with H2O. This reaction I'm not very sure whether you have seen it or not, but I had personally performed it in the school. So when the school got over, everybody was going out of the school and I went to the water tank where the water was kept. There was a little water logging also was there. I dropped the sodium metal over there and it started jumping and dancing here and there, here and there, and then pat, 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 boom, boom, boom. That kind of sound happened. People started looking what the hell happened. And then obviously the complaint went to, and basically I think there was a lot of damage happened to that water tank thing also. I think it was made up of ceramic and then it broke down. And the complaint went to principal and then they tried to find out who did it, but I don't think they got to know because there was a whole group of us. Basically, the whole class was involved, not only just me and some of my friends. So nobody could even tell who did and how it happened. Okay, so basically, this is the reaction of sodium between water. So now, this is your sodium metal, and this is we have taken water. Again, when we talk about water, water has the hydrogen over here, right? First of all, we have to understand how water splits. So water will basically, like HCl is splitting into H plus and Cl minus. Water splits into H2O, splits into H plus and OH minus. Okay. Now, when the sodium will be there, sodium will be easily able to displace the hydrogen from here. So one hydrogen it will displace, not the both. Not both the hydrogen will displace, it will displace only one. The one which is in the ionic form, H plus. So Na will lose its one electron, will form Na plus, and Na plus will displace H plus basically. Okay. Now, so what we have, Na plus reacting with OH minus, and it will form NaOH aqueous. So what we are left with? We are left with one hydrogen, H plus, and one electron. So it will form hydrogen atom. That's all. But there is nothing. We keep it as just an atom. Hydrogen generally exists in the form of molecule. So what we can say? We can say that in this reaction mixture there won't be only one hydrogen which would be present. There will be multiple such atoms will be present, and two atoms of hydrogen will combine and will form the hydrogen gas. So two of such H would be reacting together to form 2H. So basically I can say if I take 2H plus and if I take 2 electrons, won't it form H2? Just look at it carefully. If I take 2H plus in the beginning itself and 2 electrons here, I will get 2H2 because sodium is also not one. There can be multiple sodiums in the mixture. So if I take 2 sodiums over here, they will lose 2 electrons and I get 2 Na plus. Right? So in that case, I will be able to write it more nicely. That is H2. But if I'm getting 2 Na plus, in that case I would require 2 OH minus. Right? So how will I get 2 OH minus? I have to take 2 water because I had taken 2H plus also. So I'll have to balance it some way. So I'll write 2H2O. 2H2O will give me 2H plus and 2OH minus. Got it? So this will give me. So this is how we have done the balancing. So basically, I had 2 hydrogens, and I had basically not 2 hydrogens. If you just balance this, it will be a little tough. So I have to balance it overall. So I'll do 2 sodiums. So it will become 2 NaOH. If I do 2 NaOH, I have 2 sodiums same. OH. Oxygen are 2 and hydrogen are total 4. So I can just multiply to 2. You can balance it this way also, and you can balance it ionically also. If you do it through the ionic manner, it will be much more simpler and it will be sure shot correct. So what I have done, I'll again explain you this. Just look at it again very, very carefully. So I have taken H2O, which broke down into H plus and OH minus. Correct? And then I have taken Na, and Na lost one electron on Na plus. Till now, we have not found any difficulty over here. So now we will be talking about sodium reacting with OH minus and forming NaOH. Till here also no changes in the reaction at all. After this, the problem comes when H plus tries to make a bond with an electron. When it will make bond with the electron, not bond, basically it will try accepting an electron, it will become just hydrogen, and we want H2 as a hydrogen gas. So I can multiply this whole thing with 2. So automatically I'll get 2. Or I can say I can multiply this whole thing with 2 and automatically I'll get 2. But in that case, that means I have got 2 electrons, but sodium is released only 1. That means I will have to balance the sodium and the electrons also. So I'll multiply this whole thing with 2. Now sodium is also balanced. 2 electrons it has released, it has gained 2 electrons and formed H2. I've just multiplied from outside so that it doesn't become very clumsy. If I have done that, if 2 sodiums have got released, then they must have reacted with 2 OH. So here also I have multiplied it with 2. So I got 2 NaOH. Correct. But if it has reacted with 2 OH, then it must be production of 2 OH over here. I have multiplied this whole thing with 2, so that I can get 2H plus and 2OH minus. Now 2H plus here, 2H plus here, basically the one which is formed, which we had in the reaction recording the product. 2H plus had formed the 2 hydrogen gases over here. 2OH minuses have formed 2 NaOH over here. So everything is quite balanced. So see it this way. I'm not very sure how much you'll be able to get it, but you have to relate it as much as possible because these are very important things. Though it is not mentioned in NCERT in very much detail, but this is very much required for understanding of a reaction. Now similarly we have Cl2 plus Ki. So again, here in this case you would see that the chlorine and iodine are displacing each other. So basically this is about the reactivity of iodine and chlorine which are not metal, which are non-metal. So this you have to take it as a matter of fact that your chlorine is very reactive, is much reactive than your iodine. So if it will see iodine somewhere, it will just displace it. So chlorine displaced iodine, formed KCl and iodine. So chlorine will displace iodine, iodine will displace chlorine and it will become KCl plus I2. Similar way I have Fe2O3 and aluminium. When we heat them together, it becomes Al2O3 plus iron. That means aluminium has displaced iron. Iron comes out in the molten form, Al2O3 solid, Fe2O3 was solid and aluminium was solid. So when we heated them together, iron become liquid. Basically the reaction is an exothermic reaction. It has absorbed energy in the beginning, that's for sure. But after the reaction took place, there is a lot more amount of energy is getting released, which is causing the melting of iron. So huge amount of energy is releasing, small amount of energy is absorbed and huge amount of energy is getting released, which is basically melting the iron. Okay, this reaction is very important. Let's see the ionic reaction of it and understand the importance of this reaction. So let's see the ionic reaction of Fe2O3 plus Al. Fe2O3 will break down into 2 Fe2 plus 3 O2 minus. Now after this, your Al will lose 3 electrons, will become Al3 plus. Now Al3 plus 2 plus 3 O2 minus will come, not basically 3 balancing I'm not doing right now, balancing you will do on your own for this reaction. So Al3 plus O2 minus will form Al2O3 and Fe2 plus will gain 2 electrons and will form Fe. Now if you look at this reaction is not at all balanced. See, the number of electrons are different, number of ions are different, everything is different. So you have to balance this reaction on your own now. If you directly use this reaction for balancing, it is much more easier. So Fe you have 2 and here Fe you have 1, O you have 3, O you have 3, aluminium you have 1 over here. So aluminium I'll just take 2. So aluminium is balanced now, oxygen is already balanced, this iron I have to balance, that is 2 Fe over here. So that's how balancing has to be. And this is balancing I have shown you over here. I have not done the ionic balancing, that you try out on your own. These are the examples of displacement reaction. Next we'll be talking about double displacement reaction. My bad, I have rubbed everything. The last reaction what we were discussing, that is iron reaction with Al2O3, and I said a lot amount of heat will be released and because of which iron will be molten. That reaction is called as thermite welding. Thermite Welding. This is used for the welding purposes. Very, very important reaction. Okay, I just missed telling you that part. So this is used, that reaction, that is Fe2O3 reacting with aluminium, giving you A2O3 and Fe molten. This reaction is not only used for the regular welding purposes but also used for the welding of the railway tracks. Okay, and huge amount of heat gets released after this reaction. You must have seen welding happening and a lot of light and heat comes out. I mean, you can see those sparks coming out. So that spark is basically large amount of heat or energy, you can say, because energy is coming out in the form of heat as well as light, both. So this is very, 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 very important reaction. Not only in this chapter, you will be seeing this reaction again in metal non-metal chapter also. Now we'll talk about double displacement reaction. So next is double displacement reaction. We have already seen the displacement reaction and what happens in it. A stronger metal displaces the weaker metal, or a stronger non-metal displaces the weaker non-metal. If in the reaction mixture a weaker metal trying to displace the stronger metal, then the reaction doesn't take place. Okay, so this was the basis of the displacement reaction. Now we'll talk about the double displacement reaction. So now when the word says double displacement, that automatically gives us hint the two things are displacing two other substances. So basically what exactly happens over here, let's say I have AB and I have CD. So displacement doesn't happen with just one pair, displacement happens with both the pairs. Basically, A and B forms the bond and B and C form the bond. So in the earlier reaction, what was happening? There was one compound and other was either metal or a non-metal. Now here we have taken both the species which are reacting are compounds and we are displacing their ions. Their ions are getting exchanged and the products are forming. So basically A is going along with the B and B is going along with the C. So this kind of exchange is called as a double displacement reaction. But how it happens and why it happens, that we have to understand. So now I'll just explain you with the help of this and a generic example, and then we'll come up to the reactions directly. So let's say AB is aqueous in nature, basically dissolved in water, and C and D is also aqueous in nature. What will happen? A in aqueous, these all A, B, C, D, these are all ionic compounds and they split into the aqueous solution into respective ions. That we had discussed in the case of displacement reactions also. I was just doing the ionic reaction at this part. So assume that these are the ionic compounds and they'll split into A plus and B minus. Similarly, C plus and D minus will come in the solution. So basically in a solution mixture you have kept AB and you have kept CD. Both are dissolved in water, and when both are dissolved in water, basically they are not in the bonded state now. They are not in bonded state anymore. They'll just split into ions. So now in my solution, these all different ions are present. Okay. So now there is no compound in the solution mixture. The solution mixture has A plus, B minus, C plus and D minus ions present in the solution mixture or the reaction mixture. Now what happens? Now, so A plus B, A, B, C, D, all these ions are in the reaction mixture. Now, when you have understood this, let me explain the rest of the reaction through another example. Assume this AB was a pair or a couple 1, and CD was couple 2. Gulf important basically. Okay. So AB and CD were two couples. Okay. Now when they went into a dance floor, let's say they went somewhere and there was a dance floor, they just got split and they are dancing individually. Okay. Now when they're dancing individually, A and B are coming together sometimes and dancing together, and then again they are splitting and then they are reacting with other people over there. So assume there were 4 people on the dance floor. Assume A is dancing with B, C is also dancing with B, but because they are not bonded right now, they have got split. Now they are free to dance with anybody. A, and assume A is a girl, B is a boy, C is a girl, and D is a boy. So A will go dance with boy B minus, So they are pairs, they are girlfriend boyfriend, they can dance together. A also went to D and started dancing with D. Is the another boy, B boy too, right? Similarly, B B could react with his own girl, and B could react with the other girl also. If it is reacting with its own girl, no problem. If it is reacting with C, may or may not be a problem till the time they are still dancing. They have not become pairs anymore. They have not bonded right now. They have not changed their pair. So right now they are just dancing individually. They are dancing individually. They are going dancing with somebody else, but not defined themselves as the new pair of girlfriend boyfriend. So a lot of people are dancing, and after some time, A and D sees that B and C are gone somewhere. Basically, gone somewhere means they had not declared anything. They had just bonded together, and they had become new pair. New pair as in BC formed and gone. Now they are not splitting back to become the individual identities and go back to their previous partners. So now what is left? A is a girl, D is a boy, now left with nothing because their original partners have left them and made a bond and become the new pair. They also combine and become a new pair. But that's not necessary that they become or not become. They may stay individually or they may become a pair. Now, what would define that B and C had become a pair and had become a girlfriend boyfriend, and they cannot be separated now. Earlier they were separated over here when they were on the dance floor, but now they have formed a new bond, they have formed a new coupling, and now they are the new couple in the town. Basically, they are detachable. This BC, what has formed, this can be either a volatile gas or a volatile compound which may escape from the reaction mixture like a gas. It can be any volatile compound which can escape out as a gas, or it can be a non volatile compound and acting as a, or we can also call it as a precipitate, which is no more soluble, which is no more dissolvable, no more breakable. They have made their bond in such a strong manner that now they have become a precipitate or they have become gas, volatile gas, and out. Now, this A and D, which I said, were left out in the solution mixture where they were dancing. They are making bond, but their bonds are not yet strong. They don't want to be a couple, or they are not okay with making a new bond or something. They will just lie in the solution like A plus and B minus. And when we have to represent this combination in the reaction, we just simply write AD. We forcefully make them a pair or a couple. So they are not in the bonded form, but they are in the ionic form in the aqueous solution. Whereas BC can either be solid or can be gas, depending upon what compound it is forming. If it is solid, it will settle down as a precipitate. If it is gas, it will escape out of the system. This is the double displacement reaction, and this reaction will not happen. Double displacement will not happen if this won't happen. That means formation of a volatile compound or formation of a precipitate. If it is not happening, then there is no point. They'll just keep dancing together, and then they'll be just in the ion form in the solution mixture. Nobody will be bonded with nobody. The reaction change will not be visible. You will not see anything reacting and forming a new compound. They'll be just lying in the solution as small ions. Assume if it would have been a case where A, B, and let's say P and Q, these are two pairs and dancing in the solution or dancing on the dance floor, and then they are split into A plus, B minus, again P plus and Q minus. But B on reaction with Q, or B when went dancing with Q, couldn't bond very nicely or strongly, and hence again split into its respective ions in the solution. So they will just remain like this. No reaction will take place. Reaction will take place only when they bond strongly, will form either solid or gas, and then only the displacement reaction will take place. Now, how will you know whether a bond is forming between B and C is strong enough or not to make them precipitate or gas? I'll give you that data. I'll give you the data that which all different compounds can form precipitate, or which all different compounds are insoluble and remain as precipitate, or which all things are gases which you can with that you can easily see through, because most of the gases you will be able to identify. But precipitates, you may not know. I may have to list down all the different compounds which are good precipitate or which are insoluble in solution, and when they are insoluble in the solution, they are precipitates. Okay, so I hope now idea would be clear that A, B, C, D ion exchange happen only and only if one of the products, both can also be stable, both can also form precipitate or gas, but at least one will form either precipitate or gas. Okay, so now let's see some examples of double displacement reaction. So now let's quickly discuss some of the examples of double displacement reaction. First, I have taken AgNO3 and NaCl. Now AgNO3 will split into Ag plus and NO3 minus, and NaCl will split into Na plus and Cl minus. Now, when Ag and Cl will combine together, they will form a precipitate, a white color precipitate, and NaNO3 will be in the aqueous solution just like that. I have written NaNO3, we will write it like that, but they will be suspended like their ions in the aqueous solution. So one of the product is forming as a precipitate. Similarly, look at the BaCl2 and Na2SO4 reaction. So you have taken barium chloride and sodium sulfate. When we react them together, barium chloride will break down as Ba2 plus, chlorine as Cl minus, Na as Na plus, and this as SO4 minus. Now when barium and sulfate ion combine together, they form a white color precipitate and settle down. Whereas NaCl will remain suspended Na plus as Na plus and Cl minus in the solution. So that will be in the aqueous form and this will be in the precipitate form. So these are the examples where the precipitates are forming along with the other remaining ions suspended in the solution and eventually forcefully being called as a product or a compound. Okay, so this is sodium chloride, this is sodium nitrate. Now let's take an example where the evolution of gas is happening. I told you when the double displacement takes place, either the precipitate will be forming or the gas will be forming or both of them will be forming. Anything can happen. Okay, so NaCl reacts with H2SO4. This is also the preparation, this is also the lab preparation of HCl gas. Okay, so when we react them together, NaCl breaks down as Na plus and Cl minus. Similarly, it breaks down as H plus and SO4 minus. Na goes along with SO4 minus to form sodium sulfate. Okay, I think I have taken it in a wrong manner. I should not have explained it this way. Hydrogen and chlorine have gone together to form hydrochloric gas or hydrogen chloride and will escape the system. So this is your volatile product. And then another sodium and sulfate ion will remain in the solution suspended and we will call them sodium sulfate solution. Okay, so this is the example where a volatile gas is getting produced. So this is also a double displacement reaction. Now let's look at the fourth example where I have taken barium chloride with H2SO4. Both are dissolved in the water, so both are in the aqueous form. Ba will break down as Ba2 plus and this will break down as Cl minus. Similarly, this will break down as H plus and SO4 minus. So let's say H plus and Cl minus goes together, they'll form gas, will escape out the system. In fact, barium and sulfate ion will also combine and will form a precipitate. So best situation, both of them have got converted into something which is much more stable and the bonds are much more stronger than the before and it becomes precipitate, this becomes gas. So this is the example where both the products forming are either in the precipitate form or in the gas form, or one precipitate, one gas, and nothing is just lying in the solution as ions. So these are some examples of double displacement reaction. Now I'll ask you one or two questions and you will tell me whether the double displacement can happen on those reactions or not. But before that, I'll just list down all the different compounds which can settle down as precipitate or which are insoluble in water. So whichever things are insoluble in water are eventually going to be precipitate. So I'll just list it down here, you just note it down and then take that as a reference to answer my question. So here's the list of all insoluble salts. Make a note of it, read them very properly, take it as a reference to figure out in which all reactions the precipitates are forming. Note them down. So now try out these three questions, see whether the reactions are possible or not, whether the double displacement reaction is possible or not. You already have a list of compounds which are insoluble and what all can form precipitate. Look at them and then write the answers accordingly. So now let's quickly discuss. I hope you must have done this by now. So now we'll do is we'll write the probable products and we'll see whether the reaction is possible or not. So here if I do the double displacement, I'll get NaCl plus MgOH whole twice. Right? This is what the products I'll get because Mg will break down as Mg2 plus, chlorine will break down as Cl minus, this is Na plus and this is OH minus. So if ion exchange is happening, this will form MgOH whole twice and this will form NaCl. NaCl, we already know this is soluble, so this will be in aqueous state. MgOH whole twice, magnesium hydroxide, is not a soluble substance and hence will form precipitate. So this reaction is quite possible. This is a double displacement reaction. This can happen. Okay. Now come to the next. We have K2SO4 and BaCl reacting together. So I may get KCl plus BaSO4. KCl also is soluble in water. We've already seen that in the list. So this will form aqueous, and BaSO4 we have encountered multiple times. So this is a precipitate, right? This will form precipitate. This reaction is also quite possible. Come to the next one, KCl and NaOH. Now the products forming are KOH and NaCl. Both are soluble in water. So will they form any precipitate? No. Are we getting any volatile gas over here? No. So is this reaction a double displacement reaction? No. So this reaction will not take place as a double displacement reaction at all. So you have to identify the reactions very, very carefully because both of these will be in the aqueous form. Hence we can't call it a double displacement reaction. So this is not a right reaction. So I hope you would have understood how double displacement reactions take place and what is the criteria for a reaction to do a double displacement reaction. Displacement we have already done, so we have basically covered 4 different categories of reactions. One is combination, another is decomposition, then displacement and double displacement. So you will go through these reactions very properly, try to figure out more examples of it. Many times exam they ask you directly examples to write for a particular type of reaction. Many times they give you reaction, you have to balance it. So all these things you should be knowing parallelly. Moreover, as I had mentioned earlier, that they ask you the questions of the color change, that the salt has got converted into something else after the reaction has happened and the color has changed. So all those observation based questions also you need to answer. So you need to remember what is the color of a particular salt. If you want me to list down those salts also, I'll give you a list of those salts, of different salts with different colors also. So now here I'm ending this class. In next class we'll be talking about redox reaction. We'll be talking about rusting and we'll be talking about rancidity and we'll be done with the chapter. Mind it, I'll be sending you the next video by next week, Wednesday or Thursday, and once that is done, once I have sent you that video, you will have the whole chapter test after the homework done. So you may have test after next week's weekend. So basically probably Saturday, till Saturday you will do your submissions and then you will have a test on chemistry or maybe on other subjects also on Tuesday or Monday. We'll decide the date and let you know. Okay. So do this video properly, understand this nicely. If you have any doubt, drop me a message, do the assignment, and then we will have a test.